you have a C and a C, and then you have 6 H's. Okay, this is going to take some space, really. So this is 4, 4, 1, 1. I'm just going to write 1, 1, 1, 1. Okay. You add them all up. You have 8 plus 6. That's 14. Okay, this is what I mean. Put the two C's together and you count the H's. So you have what? You have 6 H's. What you do is you distribute the H's to the two C's. It's not going to be like a C attached to another C and then the 6 H's to that C. That's not going to happen. That's why hydrocarbons look like that. So in this case, ethane, in this case, is going to have distribute the H's to it. So you're going to put 3 H's on each carbon. And connect them via single bond. Now check. Do I have 14 valence electrons and is everyone happy? All the H's are happy. And the C's are happy. The C has 8 and this C has 8. So it's happy. Do I have 14? Let's count. 2, 4, 6, 8, 10, 12, 14. That's it. You're finished. Okay, what should we do about this then one? Well, let's do that. So we have also 2 C's and we have 4 H's. 4, 4, 1, 1, 1, 1. Okay, what did I say with these? You have to do is distribute. Anytime you have something, an element after it, let's say anything bigger than 1, and then a set of other elements also with a larger number, like in this case, you have the 4 larger than the 2, means you have to distribute to that atom. So this gives us 12. So distribute. Okay. So so far I have what? 2, 4, 6, 8. I have what? 12. So I have 2 left over. Well, let's see. Is this enough? Are the carbons happy? They're not. Only have 6 each. 2, 4, 6, 2, 4, 6. But you have, you know, if you check how many you have 2, 4, 6, 8, 10. So you have 2 more left over. That means it's a double bond. In fact, that's why we have, you talk about saturation and unsaturation, like saturated fat and unsaturation. Saturation means you gave enough hydrogens to the carbons, and unsaturated means you have missing hydrogens, and therefore you have to compensate with a double bond. Okay, how do I do these? Okay, to do these, you really have to pay attention to how it's set up. The way it's written for you, which is what we call a condensed formula, is the way it's supposed to be drawn. So we can write down all that you need. But generally, you should be okay with just writing it the way it is. So I start with C. These 3 H's belong to the C. And then there's a C O bond. And that H goes with the O. This is how the way it's written is the way it should look like. Okay. No, so what's wrong with this? You say, okay, well, here's, 3 H's, there's an O, and there's an H. Well, the problem with this is that this C has more than 8 valence electrons. And that's not allowed. This is forbidden for C. C, we always say that in organic chemistry, the unforgivable, again, mistake is giving C more than the octet. And in this case, so again, this is incorrect. So the way it's written, the way it's shown to you should be the way you should write it. Okay, so what about the O? Is the O happy? Well, let's check. You have 2, 4. So it's missing what? 2 more. Put them here. Okay, let's check the number of valence electrons. So you have C, you have 4 H's, and you have the O. So you have 4, 1, 1, 1, 1, and 6. So what does that give us? This gives us 10, 14. Let's count. Do we have 14? 2, 4, 6, 8, 10, 12, 14. You're finished. So again, the way it's written, so you'll need to know that, of course, O needs that lone pair, those lone pairs, otherwise not going to need them. You can't form double bonds because the C is going to have more than 8. So this is incorrect. This is correct. Lastly, is something like sulfuric acid. So you write H, H, S, and then you have 4 O's. Okay, this is pushing it really. Oh. One, 1, 6, 6, 6, 6, and 6. So in this case, you have 6 times 5, so that's 30 plus 2 is 32. All right. Which atom do you think is central? S. Okay. Now, what do I do anytime I have something like this? H is H2 and then SO4 or H2. So these are acids, right? Anytime you have these, once again, what you need to remember is that 2 of these H's, the H's are actually going to belong to the O's and not the S. Anytime you have something like anything followed H2, even if it's CO3, H2, or H3PO4, just be aware that those H's belong to the second atom or the second set of atoms. They don't belong to the carbon or the phos. Again, they will violate the octet rule. S is going to have now more than 8. And that's not allowed, at least at this point. So you go like this. You put the H's, you put the O's, and you attach 2 H's to 2 O's. And then you check. So you put the lone pairs. This one only needs 2 lone pairs. This one only needs 2. This one only needs 2. And this should now give you 32. Here we have 8 plus 8 plus 8 plus 8. That's 32.